Hello everybody, hope you are all doing well. This has been a while since I've posted a video, so today we're going to look through some logarithms. And I've got this question here, and it's all about manipulating the rules of logarithms to eventually solve an equation. We're going to use parts A and B to help us solve part C. So just before we dive into the actual solution, let's have a reminder of the laws of logs. So the first one is when we've got a log base A of a number or the same number A. Okay. Now if we think about how powers work, well, we know that A to the power of 1 is equal to A. So therefore log base A of A must be equal to 1. The next one that we're going to make use of in this video is log base A of a product BC. Now once again, if we think about how powers work, then if we have something like A to the B times A to the C, then this will be A to the B plus C. So as a result, log A of BC is log AB plus log A of C. So we can see these parallels between the log laws and the laws of indices. Okay, and this is no coincidence. The final one we're going to make use of in this video is the division. So very, very similar to the last one, but if we've got log base A of B over C, then this is going to be log base A of B minus log base A of C. And once again, this comes from the following indice rule. A to the B over A to the C is A to the B minus C. And I suppose naturally the last one we'll make use of is if we've got log of A of B equals C, then this tells us that A to the power of C equals B. So what I'm going to do is just quickly number these. So number 1, number 2, number 3, and number 4. If you are new to the channel, please do subscribe at this point. Okay, so let's have a look at the question. We've been told that log base 3 of x is equal to a. Now for pi, it says find in terms of a log base 3 of 9 times x. So straight away we're going to make use of rule number 2 here, and we're going to break this down into log base 3 of 9 plus log base 3 of x. Okay. Now let's think about log base 3 of 9 first. Well, what power do we raise 3 to get 9? And that's going to be 2. And then log base 3 of x, well, that is exactly what we were told at the start is equal to a. So this must be equal to a. So that's part A done. Let's have a look at part B. Well, this time we're going to make use of rule 3, the division rule. So this says that log base 3 of x to the 5 over 81 is equal to log base 3 of x to the 5 minus log base 3 of 81. Okay. Now we have another rule which I didn't actually write down below, but this says when we've got log base of a number to a power, what we can do is we can take the power to the front. So this is actually equal to 5 log base 3 of x minus, and then log base 3 of 81, well, we know that 3 to the power of, well, what power do we raise 3 to get 81? And that is 4. Okay, and finally, log base 3 of x, we already know is a, so this, all in all, is 5a minus 4. Okay, so we've got 2 parts completed now. And now we look at how we put this all together. Okay, because in part C, it says solve this equation for x, where we've already done all the hard work, really, in parts A and B. So from part A, we know that log base 3 of 9x is equal to 2 plus a. And from part B, we know that log base 3 of x to the 5 over 81 is 5a minus 4. Now, just before I go any further, because we want to solve for x, I'm going to take our original result, which said that log base 3 of x equals a, and write this in terms of x. So by our rule at the bottom here, number 4, if we have log base a of b equals c, then this tells us that a raised to the power of c is equal to b. Okay, so what this means is then, if log base 3 of x equals a, then this must mean that x is 3 to the power of a. Brilliant. So our plan now is to find a and then substitute it into here. Okay, so let's collect up our like terms. We've got plus a plus 5a, and then we've also got a minus 4 and a 2. So what do we have in total? Well, we've got 6a minus 2 equals 3. So this must mean that 6a equals 5. And so a is equal to 5 over 6. Okay. So putting this all together then, our final solution, we know that a is equal to 5 over 6, so x is equal to 3 to the power of 5/6. And to 3 significant figures, we're going to resort to the calculator. Let's see what we get. So 3 to the power of 5 over 6. And on my calculator, it's 4 significant figures we want. 2.498. 2.498. And that's to 4 significant figures. Okay. So this is quite a tricky logs question. If you look at the total number of marks, we've got 2 marks for part A, 3 marks for part B, and 4 marks for part C. So a total of 9 marks there. But as long as you are confident with these 4 rules, this question is really, really nice. Really hope you enjoyed that. If you've got any comments, please leave them below. Please leave a like on the video. And until next time, have a great day.